This conference will now be recorded.
Yeah, Wells Fargo Bank and Pegasystems Private Limited in Hyderabad, and Wells Fargo both in US and India. So I have a rich experience in multiple industries, working across different types of industries. Right, so today I will be just taking you through a little bit of introduction to big data, Hadoop. So we are going to talk about a few definitions here. I'm not going to be any technical. So the main objective is when you go out of this meeting or this call, you know what is big data, what is Hadoop and Spark related technologies, and then later we'll definitely go into detail about each of these technologies. So any questions before I go into the details? Okay. So you can actually interrupt me at any point of time. So you don't have to wait till the end if you have any questions. You can also send a chat message, but I'm not continuously looking at it. Whenever I see that, if your question can wait, I can answer them at the end. Okay. Otherwise, you can always unmute yourself and then you can start asking your questions. Okay. So before we actually go into the actual description of what is big data and Hadoop, right, I would like to talk a little bit about the prerequisites. Because this is a very advanced technology itself, so there are a lot of dependencies on our prerequisites that you may already have to know, without which it's a little difficult to get to these things. Right. So the first thing that you may want to have is a programming language. It could be any programming language which has OOPS concepts in it. Because during the first phase of our course, right, so which is Hadoop, you may not need actually a lot of programming thing. But during the second part of the course where we are going to learn about Spark, so it is built on a language called Scala. So you definitely need to do some kind of programming. So you should show a lot of enthusiasm in learning a new technology or a new language, without which you may not be able to be successful, right? So I'm going to teach you Scala, so you don't have to worry about it. But during the next few weeks, right, if you are able to get hold of some object-oriented technology, right, you can learn about the basic concepts of these things, then that would greatly help yourselves and also me, because I don't have to go very deep into the concepts of object-oriented things and all those things. But yeah, I will make sure that you don't have any prior knowledge, and I'm going to teach you like that. But if you are able to do some things from your side, that it would be definitely helpful for me, and of course it for you also. So that is one of the first prerequisites. And for Hadoop, if you're learning Hadoop and we're going through various components in Hadoop, right? So it's a must that you need to have a knowledge of SQL, right? Because here we are talking about big data, we are doing analytics, and then we are running queries, right? So definitely a prior knowledge of SQL is required. But it's not a, you can actually learn it in any online site if you have not done before. And I'm also going to give you some resources if required, so that you can catch hold of some online resources and quickly go through them, right? But before that, yeah, because this course is not about teaching SQL. So basically, how do you use SQL while running queries? So I expect that each of the participants have the SQL knowledge, right? And the third one and the last one is not a requirement though. If you have a Unix background, or not background, I should say, if you have a basic knowledge of Unix commands, then that should be great. Otherwise, you don't have to worry. Again, I'm going to give you some resources. You can always practice the things, and then during this course also, it will be mostly it will be theoretical, of course, but mostly it will be practical. So you will be doing a lot of things. We'll see. There are many people, right? So we'll have to see how I can schedule the lab sessions. Usually, I ask one of the people to actually do the things so that everybody can see it, and I guide them, right? So during that course, you will actually learn the Unix commands if you have not done Unix before. But again, I'm going to give you a couple of textbooks or online books where you can actually see those things and then practice, right? So with these prerequisites, right, unless you have any questions, I would like to jump into the agenda today. So yeah, I'm going to give you some introduction to big data, Hadoop and Spark. And these are some of the topics that I'm going to touch. So first we're going to talk about what is big data, of course, the definition of it, and then background of it, and all those things, and what are the challenges that big data is facing, and what are the technologies that support big data. And then we are going to enter into Hadoop and Spark and all those things. And why do we require this? What are the advantages and all those things? And Hadoop has its own ecosystem. So I will tell you what is an ecosystem and then what do you do with it. And then finally, we have the Hadoop use cases, where exactly Hadoop is going to be used, right? So these are the topics that we're going to touch. So next, I think around 40, 45 minutes, if not more, we'll be talking about all these various topics, right? Okay, so let's get straight into big data. So, usually I'm very interactive. So I don't want only me to be talking. So if you have any ideas or if you have if anything you want to put forward, you can always unmute it and then ask a question or anything that you want to talk. But the first thing I want to initiate this discussion. So I want to keep it like more like a discussion rather than I am teaching something. So the first question that I have is, what is big data? So I am sure you might have, I was told that you attended a couple of demos. So anyone, can you briefly say, just in pure English terms, I am not looking for a textbook definition, what is big data? Anyone? Maybe I think one answer should also be fine for me because it's a big group. Anyone?
Yeah, hi Ravi, this is Adarshi.
Yeah.
Yeah, actually, big data is like we have 4 V's, right? The problem which we are facing related to data velocity, veracity, variety. Okay,
Okay.
so data.
Yeah, velocity. Yeah, we'll define. Those are very low-level terms. But in general, that's why I said in normal English terms, right? So why are you learning this course, right? That's the kind of a question I'm going to ask. What is big data at a very high level? What is the problem?
Okay,
Why do we need
data
big
is
data?
increasing, yeah, every day, right? So this relational database, they can't store the data and they can't manage and process, right?
Yes.
So the
Why
data.
it is not able to manage? What is the problem?
Yeah, yeah, because it is a structure, it is not structured data, and
Not
data is
structured
streaming continuous data every day. Like,
data is structured, right, in databases.
yeah, in database structured, but in the big data, the data is like unstructured.
Okay, so if
So
the data is structured, then there is no problem with databases.
Because of the volume as well.
volume, volume is more, and data is streaming continuously. Like,
Okay. What is volume?
increasing. Data is increasing. Volume means more
Okay.
data. You can say. Yeah.
Okay. Yeah, thank you. Thanks for your answers. Yeah, pretty much the same thing, but yeah, I would like to throw in more insights. So here, usually what people think is whenever we talk about big data, right, we say that big, as the name suggests, right, huge data, right? As I got the response, right, volume means huge data. And one question that comes from this is, why is data increasing? And why is this a problem now when we have been using the data from maybe 30, 40, 50 years, right? Why you are saying that now it's data is increasing and I'm having a problem, right? That could be one of the questions that we need to ask.
Yes.
Yeah. So, yeah.
Because these days we have social media coming up, and lot of people were using different kinds of applications, such as uh, anything. It could be automobiles, social media. So many industries are growing with the latest technology, so people are tend to use it than before.
Yeah.
So data is
Yes. Yes. Perfect. Okay. So that's what is the problem. Yeah. So here, what happened was typically whenever we have some kind of data, right? Data means what? It's information about people. It's information about whether you want to store employee records, whether you want to store user information, any kind of thing, right? We store usually the default thing is to basically store the data in a database, right? Because that's where you store the data in a particular organized format and then keep storing the data. So for 30, 40 years, we never faced any problem because people were not that much aware of internet, right? The main killer is here the internet, right? So that is where that is the place where we are going to have a lot of data. Either you upload data or download data, right? So as and when the time has moved in, right, and when we entered into the new millennium, like into the 2000s, right, then the internet access has been very, very cheap, and everybody is able to afford internet. And at the same time, a lot of these social media companies, as you rightly said, have come into picture, and people just started accessing them, like YouTube videos. Like people are just left and right creating videos and uploading them. And as and when you keep on uploading the data, right, then it's really consuming a lot of space. And then the databases, usually they store it on a single machine, right? Whenever you talk about an Oracle database or you talk about a MySQL database, right, they have a specific size on which you can have a hard disk, and then you can store the data. But what happens when you keep on pouring data into a particular system? After a certain amount of time, it will become slow, right? Suppose if you maybe in the 90s, right, when I passed out in 97, right, I did not even have a email account, right? Not the Gmail was not popular at the time. At the time, Yahoo was the most popular emailing thing. I never had, I think, email account till I did my first job, right? So because I never had access to internet, I don't even had a mobile phone to talk. So very few people had these kind of things, right? But when we entered the new millennium, yeah, everybody is having the mobile phones. They can actually order everything on the internet, and everybody has multiple emails. Suppose if I'm storing an email, right, I'm giving an email to my friend. What is actually happening? When I register with Google, Google is actually storing some information in the internet, in their server, right? Now, initially they might have a few thousand users, but as and when the time moved and when people got access to the internet, right, everybody started creating accounts. And once I send a message to my friend, right, where do you think the message is getting stored? It's not going to the other person's computer and getting stored, right? It is when you send a message to your friend, it is actually going to the Google server, and the message is stored maybe in some database server, right? Now, as and when many people are increasing, and then many people are giving messages, right? When I send a message to my friend, that when my friend opens that email, what is happening? The email is sending a request to the server, and out of millions of records, it is querying the data and then getting only the messages that my friend has to read, which have come from me, right? So it's not just about storing the data; it's also about querying the data, right? There are two parts to the data. Okay, you can keep on adding as much hardware as you want on a server, but it's always crucial that when you read the data, whether you are getting the data as quickly as possible or not. See, usually when we open a Gmail, right, when we click something, you get the message very fast. So out of billions of records, right, it is able to fetch the record and then show your message, right? But over a period of time, the data has been continuously increasing because of, as you said, social media, internet. Everybody is trying to store as much data as possible, right? If you go to the internet, if you go to Amazon.in, right, or Amazon.com, you are actually doing some shopping, but behind the scenes, they're collecting a lot of information so that they can understand the way you browse it, what are the things that you are trying to search for, so that they can recommend things, and all these things will happen, right? So that's why in the new millennium, people started storing more than the data that is actually required, right? So over a period of time, yeah, we usually talk about the volume of the data. We call it as the velocity of the data or the variety of data. We will actually describe these things very briefly. So the first thing that comes to our mind whenever we're talking about data is the volume of data. So suddenly the amount of data started increasing because of these various reasons that we just discussed. And going into 2020, which is like current year, right? So 40 zettabytes of data. So how do you actually store your data? How do you measure your data? The data measurement happens with bytes, kilobytes, then we have megabytes, and then we have gigabytes, then we have terabytes, and each one is a 1024 of the previous one, right? 1024 megabytes is a gigabyte, 1024 gigabytes is a terabyte, and then 1024 terabytes is a, anybody? 1024 terabytes is a
zettabyte.
Zettabyte is the last one. It's a petabyte. 1024 petabytes. Do you know after that? It's an exabyte. It's an exabyte. Yeah, 1024 exabyte is a zettabyte. So till you come to the zettabyte, right, there are already a lot of things. So which means that, so if you're talking about 40 zettabytes of data, you're talking about 43 trillion gigabytes, which is like, excuse me, huge information of data, information, right, that you are trying to store in your computers. You can buy as many hard disks as you want and attach it to your computer. Of course, it may not support it, but the problem is not with just with the storing, it's also with the querying of the data. If you store the data, it is not the end of the world, right? Somebody needs to access the data and then try to query the data and see what is there inside, right? That's what is about the data. So when the volume of the data, when it continuously increases, right, that becomes a problem, right? So this problem is what we are calling it as big data, right? And also volume is only one of the dimensions of big data. So big data is not a technology, it's not a software, it's not anything. It's just a word or a term to define a particular problem that you're getting with the data, right? So lots and lots of people are having internet connections, and once you have lots and lots of people are having phone connections, which means that whenever you make a call, the call company, right, the provider company stores a lot of data, right? And many people these days, of course, in US and many other companies, right, they are storing lots and lots of data, which they have not done prior to this millennium, right? So that's why volume has actually become a very big problem when you are trying to query your data, right? So that is one of the dimensions. But here, usually when we talk about volume, right, it increases over a period of time, right? So let us say if I put up an online company, right, let us say I'm an entrepreneur, and then I wanted to sell products just like Amazon.in, right, or Snapdeal or whatever the retail sites, right? Now, when I initially set up a company, right, not many people come to my site, so I just buy one server and then I store data about the customers who are accessing my site, right? But as and when I become popular over a period of time, let's say 6 months, then I may start seeing some problem, because many people are coming to my server and then storing a lot of data, and that's when I'm going to actually face a problem, right? So when your volume increases, right, it might take a little bit time. It's not always that it will take time. It might take a little bit of time, but it gradually increases, and you can actually plan for it, right? But you still have a problem, right? When it crosses beyond a certain limit, right, you will have a problem, right? Because databases, right, when you keep storing the data, they have like 20 terabytes, 30 terabytes. Now the capacities have increased, but in the good old days, like when you talk about 2000s, right, like 4 terabytes, 5 terabytes was the maximum. If your data is more than that, your database is not able to handle any queries. If you run a query, right, it takes 8 hours, 9 hours, 10 hours, and you will have to go to sleep and then come back tomorrow, and only to see that your query has failed, right? So that's what is the problem with the volume. Now, the other side of it is, in the current world, right, as somebody just now mentioned, the data is coming continuously, right? So usually when we talk about data, we talk about two different things. One is batch data, right? So batch data is something that I collect over a period of time, and then I run a query and wait for it for maybe 1 hour or 2 hours. I will not wait for the result. I will come and look at the results maybe later. But if you look at something like a stock exchange, right? If you look at the New York Stock Exchange, right, then there, if you look at I'm sure many of you know how the stock exchanges work, right? Like BSE, Sensex, and all the things. Lots and lots of information is being done when the people across the world, right, try to buy and sell shares, right? Like if you do mutual funds, and a lot of information will be traded. And here it was observed that 1 terabyte of trade information during each and every trading session. 1 terabyte is a huge data, right? In one trading session, which means that you are actually dealing with a lot of data within no time. With the volume, right, it grows over a period of time, But when you talk about the velocity of the data, we are talking about the rate at which the data is coming into your system, right? So in the next 1 second, I'm going to get like 1 terabyte of data. So how I am going to run this queries on this data if the so much of data is going to suddenly come and sit in the data, and it's not going to stop. It's going to continuously come. Suppose if you look at Twitter, right? In Twitter, everybody is tweeting, like millions and millions of people are tweeting on Twitter, right? Now, if you want to do some analysis on Twitter, right, I will get like million messages at a single point of time. I cannot say that I will take all these messages, put it in some database, and I will query. I will do query later, right? I cannot do that because that messages become very old if you do your query later, because in Twitter, right, everything is real time, right? Everything is generated now. People are tweeting now. That message will become old just after 5 minutes, right? So this is called as real time querying, or we sometimes call this as streaming data. The data that is continuously flowing into your system, and then you have to query the data then and there to actually have insights into that particular data. So this also has increased in the newer millennium, which was not there before, and this also has become a problem. So velocity is basically the rate at which the data is entering into your system. It's not only about the volume, it's also about the velocity of data that is you're getting. So today, we're actually seeing something like Internet of Things, right? I'm sure you might have heard about IoT, right? So IoT is all about generating a lot of data by getting the data from different drones, going there and then calculating temperatures. Even if you'll see, I think you might have heard about connected cars in US, where they put a lot of sensors in the car, and then those will be sending information to the dealer servers, so that if something happens while driving, the information directly goes to the dealer, and then the dealer is able to actually help you then and there immediately, right? So the technology is continuously changing, and your data is also rapidly getting access, right? So the second dimension that you are facing now, or the problem, is the velocity of the data, right? So volume, velocity. So these are the couple of dimensions of your big data. And the third, and also a very important, I think we started the discussion with this, variety of data. So here, mostly in the our good old days, right? We had just simple databases. Our data used to arrive at us in a very simple format, in the form of rows and columns, and that's what we used to call it as structured data, right? So what kind of data you call it as structured data? So how do you qualify a particular data is a structured data? Anybody who has knowledge about databases, something. So how do you qualify that a data is a structured data? What is the one parameter that defines that it's a structured data? Anyone?
The data which is properly ordered, so which is in rows and columns.
So if you take a CSV file, right, it is also kind of a rows and columns, right?
Yes.
You have a comma separated thing, and also it is. So is it structured data?
Yeah, yeah.
So a CSV file is, you know what is CSV file?
Yes, yes.
So CSV is a structured data?
Not sure.
CSV is not a structured data.
Okay.
Okay. So here, whenever I say structured data, right? Yeah.
Anything coming from databases, if you store the data, it will be structured data.
So what is the unique feature of a database? Why you are calling database as a structured data?
So unique feature is, it is like it will have individual schema, like it will have a lot of rows.
Yes, the word I'm looking for is the schema.
Right. Yeah.
So any data which has a schema, right, is what we call it as structured data, because you're able to understand exactly what type of data it is. So usually databases have, not usually, all our relational databases are built on schema. What is schema? You have a data type, you have a column name, and every column, every row that you are storing in your database, right, has exactly the same number of columns. So if you're talking about an employee ID, employee first name, last name, date of birth, gender. So if you take two employee records, right, they will always have the same number of columns. Row 1 and row 2 will exactly have, they're completely structured. So every row has its the same schema for all the rows of the table, right? So that's why we call it as a structured data. But now what has happened after the new million, and when people started using this Twitter. So if you look at this, right, people are wearing a lot of wearable devices like what do you call for pedometers and all those things, right? And then people are using Facebook, people are using YouTube, tweeting, and if you look at the numbers, they are very staggering, right? So 30 billion pieces of content are shared on Facebook every month, right? These are not normal numbers. 4 billion plus hours of video are watched on YouTube, and 400 million tweets are sent on a day by about 200 monthly active users. So here, when you actually generate this much amount of data, right, you cannot actually store the data in a structured manner, right? It's very difficult because the data is so huge, and you cannot just say that every record is going to have exactly the same number of columns. So that's where they actually come up with something called as unstructured data. So in unstructured data, right, you have the data, but you may have data for some columns, or for some records, right, you may not have any other columns. You might have one, suppose for one employee you have first name and last name. For the other employee, you may have only a name, right? So your data is not at all structured. And more importantly, you don't have a schema associated to it. You have a lot of data, but absolutely there is no schema. So schema means the data types, how you basically define your data. So if I talk about a CSV file, right, comma separated file, it contains only the data about the data set that we are talking about, right? It doesn't contain any information about the schema, but it is very easy to store. You don't need a database like kind of a thing, because database needs to store a lot of the software itself, and its capacity is also very less. And if the data increases, right, the querying process also takes a lot of time to actually get the results, right? So we call it as a latency. The latency increases when your data getting stored on your database increases, right? So that's why what people have started doing is like people like Facebook, Twitter, because these were the most commonly used applications during that new millennium, right, 2003, 2004. They started storing their data in unstructured format. So here, there are many formats which people actually use. So people use like JSON formats. So what is the JSON? JavaScript object notation format, which contains keys and values. And people started storing it in XML, and then of course the CSV. And there are many formats which has its own advantages and disadvantages to store the data, right? So these are actually called as semi-structured data, not exactly unstructured data. They're actually called as semi-structured data, right? So semi-structured means they have a structure but don't have a structure, because CSV file has comma separated things, but it doesn't have a schema. It is a little bit structured. If you take a JSON file, it has keys and values, but it doesn't have a schema. So we call these kind of files, right, as semi-structured data. And if you're just taking a sample text data and then putting it in a Word document, right, it doesn't have a CSV kind of a thing, key value pair of thing. It just has random data. And if you take a music file, it is actually an MP4 file. So they are usually called as unstructured data. And unstructured data is very difficult to process. Suppose, let us say somebody has given you this JSON file, and now I want to run SQL queries on top of this, because ultimately when you have some data, right, you have to run SQL queries to analyze the data, because everything in this world is about analytics, right? So if I have a company, and if I have to make sure that my company is working well, I need to make sure how many refunds and returns that people are doing, right? It has to be kept to a minimum, because if I keep on doing only returns and refunds, right, my company will not do good. So that's why I need to do analytics on top of my data. But if I get a JSON file, right, definitely it is very difficult to run SQL queries, because SQL is only for databases, and this data is not meant for databases. And each format is its own way, and you need to write separate softwares to actually query this data, which is going to be a lot of headache. And if you have hundreds of formats, right, querying this data is going to be a nightmare. So that's why, and the problem is many of them are actually using this as the storage, because they said that, okay, let me first storage it, I will query it later with whatever technology I want. And people started facing a lot of difficulty when they want to query this particular data, right? So that's why the variety of data is also a big problem. So when I talk about big data, right, I talk about volume, I talk about the velocity, I talk about the variety of data. So these are the three dimensions of big data. And unless and until I solve these three problems, right, my big data is, I'm not able to solve the problem. So whenever I'm talking about big data, as I already mentioned, it's not a technology, it's a problem. It's a problem that people are facing in terms of volume, velocity, and variety of your data. So we have to find a solution, or during that time, right, like 2000, they had to find a solution quickly because data is increasing and people need to store the data, process the data, show dashboards on the internet browsers. So all these things have to be done. And also there is another low key dimension called veracity. So if you just store the data, it is not going to suffice, right? You have to basically store the right data. If you're not storing the right data, even if you query it and if you're not getting good insights, right, then it's a problem. So that's why veracity and value, validation, there are many V's. So we call this as V's of big data. So the most important V's are the volume, velocity, and variety of data. Okay, so this is what is all about big data. And if you want to define it as a textbook term, right? So yeah, you can see it on the screen, right? So big data is a term applied to data sets whose size is beyond the ability of commonly used software tools to capture, manage, and process the data within a tolerable elapsed time. So this actually defines what is big data, right? So you already have a lot of data and the data is continuously increasing because of whatever reasons, digitalization, internet, and whatever may be the reasons, right? And your existing tools like databases and other ERP systems, right? They are able to hold the data up to a certain time, but because of this volume, velocity, and variety, right? Those tools are not able to do their job very well. Like they're not able to capture, manage, or even process the data. Process is basically querying your data, building dashboards, building graphs, and all these things. And the whole thing has to happen within a tolerable elapsed time. See, when I go to a website, right, I need to get the answer within seconds, right? Not even seconds, milliseconds, right? So if I'm waiting for 2 or 3 seconds, right, I get very impatient, right? I want to go to a different site. So that's why this data querying is the most important thing. People need this particular query very quickly, otherwise they will lose customers. So that's why over a period of time, this has become a very big problem for companies, and they wanted to find a solution. But you know, Gartner is a research company which does a lot of research on the new technologies. So they predict 800% data growth over next 5 years, right? The data is only going to grow because people are storing the data. They want to capture the customers and do a lot of things. And 80 to 90% of today's data, right, it is unstructured data. So it becomes even more difficult to actually store the data. Of course, storing is okay, but processing the data gets even more difficult, right? So that's why it has more problems than solutions. For the big data, it knows what, it is able to define what is big data, but unless and until you find a solution, right? Because databases, when you run a query, it is taking days. I have seen companies where they run a query and it takes days to actually execute those queries. But if the query fails after a certain amount of time, right, it becomes even more tough. So what are the challenges this big data is facing, right? So I'll quickly go through a couple of points. So how can we capture and deliver the data to right people in real time? Because everybody wants quicker answers. A manager wants to view the data in a certain way. A CEO wants to look at the data in a certain way, right? And how can we understand and use big data in its variety of forms, right? It is coming in different forms. Some data is in CSV, some data is in JSON, some data is something else, right? Some custom formats also. So here in any of these things, right, how do I store this data? So where do I store this data? Because data sizes are becoming increasingly big, and if you are not able to store in the hard disk, right, it's very, very difficult. So what is my computer's computational capacity? How much can my computer process the data? See, usually when we buy a computer, right, we actually take up, usually look at three different things, right? See, when we buy a computer, right? So what are the three things that we look at? First one is the hard disk. So how much big hard disk we want? Yeah, 1 terabyte, 2 terabyte. These days it is increasingly bigger hard disks. Now, what is the second one? We look at memory. How much memory my system is going to have. And the third one is CPU, right? So here, the more the hard disk, we can store more data. The more the memory, I can load more processes into my memory, and the CPU, I can execute more process parallelly, right? So now, for every machine, right, there are certain limits, right? Can I just store 1000 terabytes of hard disk in a particular machine? May not be, right? Because every machine has a capacity. So if I talk about the memory, right, every machine has a ceiling for your memory also, maybe 64 GB, right? Maybe you actually start with, maybe you say that, okay, I have 12 GB of RAM, but I can increase this RAM, but it cannot go beyond 64 GB, right? Because there are hardware limitations. And similarly, CPU is measured in terms of cores. So dual core, dual quad core. So you have 4 cores, you have 8 cores, and you have so many cores. And the more the number of cores, the more parallelism that you get within your machine, and you can process it better, right? But for each of these things, right, there is a threshold value. After, let us say, 16 cores, you cannot actually increase the hardware. After 64 GB, you cannot increase the RAM. After a particular thing, you cannot increase the hard disk. Now, let us say if I'm storing, let us say 10 MB of data, then it is pretty much, I can store it in memory also, and I can also use the cores and then run a query. But now, as and when over a period of time, this data is increasing. So 100 MB has become 100 GB, right? And this 100 GB has become 100 terabytes, right? One thing is, where do I store this data? Even though somehow I attach disks and store the data, right? When I process this data, right? These days, the hard disk is just increasing like anything, right? You get hard disks in terabytes now. You can have a 4 terabyte, 2 terabyte hard disk even for a personal computers, right? Of course, servers have a lot of hard disk, but is the memory also and CPU also increasing in the same order as the hard disk? Definitely not, right? Because your memory is always 12, 15, 20, 30, 60, 100 GB like this. But your hard disk is actually storing more and more. The capacities are increasing by the day, which means that you can store a lot of data in your hard disk. But that is actually a problem. If you're just increasing only the hard disk, and if your memory and CPU are not just increasing, right, then when you actually run a query on this 100 terabytes of data, you don't have enough memory. You can increase it, you can keep on increasing to its final value, but beyond 64 GB, your data is 100 terabytes, which is like very huge. So it has to keep on changing the data, query the data, give it to the CPUs, and then do it. It will take ages to process your data, right? So when you have some data, when you have some memory, CPU, hardware, and when you are increasing your CPU and if you are increasing your hardware, right, to make sure I'm going to query the data quickly, we call it as vertical scaling. Basically, you are scaling your system so that your queries can be handled. Let us say if I'm trying to query a data which is 10 MB in, let us say, 0.1 second, right? Now, if I'm trying to query 100 GB of data, will it take the same time? Definitely not, right? Because it has to load this much amount of memory, and then CPUs, all this thing will take time. So as and when you're increasing the data, your response time also increases, which is actually not a good thing, right? Suppose if I have a petabyte of data and I will say that I will tell my user when they click on the internet a button, right? They will say that, okay, I will give you my result after 10 minutes, right? Nobody is going to stay on your website, right? But the problem is you cannot just keep on increasing your hardware because vertical scaling has a limit. You cannot keep on increasing your data like anything. So that's where the problem lies, right? So here, when we talk about this data, right, the computational capacity is very important, and over a period, the storage capacities have increased, but not the access speeds, right? The memory, the CPU, all these things have not increased in proportion to your CPU. Suppose if I want to process 100 terabytes of data, right? If I just give you only one machine and somehow I'm able to store the data, and if I scan at 50 Mbps, it takes 23 days to process your data. Let us say I gave you some customer data and I want to run a query for 100 terabytes. And 23 days definitely is not going to work. Nobody is going to wait for 23 days, right? Now, what you do? You try to increase your memory and CPU on your system. You increase it to the threshold values, but this might actually come down to, let us say, 17 days, if at all. Yeah, I'm just throwing some numbers here. This is also not good enough, right? So even 17 days, even 10 days is not good. But the problem here is the single machine is not able to handle the huge amount of data. So now what I'm going to do is, instead of just one machine, since it is not able to do the thing for me, I'm going to take a 1,000 node cluster. A node is nothing but a machine. I will actually talk about node later, but a node is nothing but a machine, right? So instead of one machine, I'm going to actually give you 1,000 machines, right? So here I'm going to have, let us say, 1,000 machines, right? So all these machines, right? I have, let us say, 100 GB of RAM, and I have a lot of CPU that I can have. That is the maximum I can use, right? So now what I can do is, since I have so many machines, instead of using just one machine, what I will do is, whatever the data that I have. So let us say this is my 100 terabytes worth of data. Let us say this is my 100 terabytes worth of data. Now, previously, I was processing this data only on one machine, which is taking like hell lot of time. But now what I will do is, I will break this data into a lot of pieces. So maybe I will make it into 1,000 pieces because I have 1,000 machines, right? And what I will do is, I will copy each piece to a different machine. So I'm going to put all these 1,000 pieces in 1,000 different machines, right? Now, the query that I was running on a single machine, somehow I want to run it on each of these machines. Same query, right? Because my data is now on many different machines, right? So now if I do this right, my query will be faster because each machine has its own CPU, its own memory, and also the hard disk. Then when multiple machines work together on smaller data sets, right, they actually produce the results very quickly. But the only problem is, you have like 1,000 outputs because each machine is querying the data, right? What you have to do, you have to combine the data from all the machines, and then you have to come up with the result. Suppose if I say what are the refunds and returns that happened in the last 6 months, right? So I have a customer file which I actually distribute on all these machines. So each machine might have given like 10 refunds here, 15 refunds here, and all these things. My CEO is not going to go to each machine and then collect the data, right? Your system has to basically collect all of them and then give you a single answer, right? So this is called as distributed computing. So this is called as distributed computing, right? And distributed computing gives us horizontal scaling. So previously, we have been using vertical scaling where there is a limit to the vertical scaling. The limit is the machine's hardware. But here in horizontal scaling, right, if I were having more data, I can just add more on machines. I am going to increase the capacity horizontally. So the more the machines I have, right, the better the processing I'm going to have, right? So this is basically a technology which was there from ages. But the problem with this kind of technology is, who is going to do all these things, right? Suppose let us say you are a database developer or a Java developer. When you're running on one machine in database, you run a fire query and you get the result, that is fine. But now with this big data problem, right, you have to first split the data. So do you know how to split the data? At least I don't know. How do you know how to put this data on many different machines? I don't know, because it's you have to basically going out of your machine and then putting the data on many different machines. How do you know how to run the query on multiple machines at the same time? What happens if a machine fails? Right, when you manage multiple machines at the same time, right, there might be some memory problems, there might be some fluctuations in electricity, some machines might go down. So if some machines go down at the same time, right, you will have a problem because you will not get the 100% result. So that is what the problem is having with the distributed computing, and people had to learn very low level languages like C, C++, and they have to actually take care of all these things. So they have to take care of hardware problems, processing and combining the data from multiple disks, which is very, very difficult. And also our traditional systems like databases, right, they cannot scale. As I just told you, right, if you try to scale them, they become very expensive. Increasing the RAM, increasing the CPU, it's a very, very costly activity, right? And we don't know whether it will work or not because they are not proven. You cannot just take two databases, Oracle databases, and then try to connect them together, right? It will not work. They are not reliable. So we know that the problem is big data. The solution is not vertical scaling. The solution is horizontal scaling. But the problem here is, how do I do that? Because as a database developer, as a Java developer, because those are the roles that we currently play, right, to query the data. So I don't know how to distribute it and how to process the data. I know what to do, right? What is my business use case? Finding out the number of refunds and returns. But now the developers have to actually do many things in order to handle these two things, right? So it will take ages before you actually find a solution. Even though it is very good, the horizontal scaling is good, it's very difficult to do all these things, right? So that's why we need to quickly find some technology which actually supports big data and does these things all behind the scenes, and we can concentrate on our own business logic, right? So a lot of companies, right, which you see on the right hand side like HP, Vertica, Greenplum, Astrodata, Netezza, and Microsoft also has products where they try to take advantage of this, and they started using multiple machines. And here, if a machine breaks in between, right, you have to restart the whole process. And that's a big headache in most of these technologies, right? Even though you have technologies, the hardware becomes very expensive. And also, there is a distributing software available to do all these things, even though it is not great. So the software was also licensed, and it is also very expensive, right? So these companies had no choice but to invest on hundreds and thousands of machines, and in order for them not to fail, they had to invest a huge amount of things on the hardware and software. And if they don't get the return on investment, right, those companies get closed. And it happened in 2005. Many companies started using these softwares, and then they were not able to handle these costs, and they started to close down, right? And at the same time, into the market, a new software has come, which was called as Hadoop, right? So the main aim of this particular software, right, is to solve these two problems, right? So the first problem, the software related problem, right? Hadoop was created as an open source software. So anybody knows what is an open source software?
We can use it with
Sorry?
It's
free of cost.
Yeah, it is basically free of cost. Means you can go to a company called Apache, a site called Apache, and you can directly download the software. And this software is not developed by any single company or single person. It is basically created by a lot of people have joined together, and they actually contributed code and then built a software and gave it to Apache for licensing, and you can actually download the software and use it. But that is the advantage of it. But what could be the disadvantage of this software? What happens if you basically find a bug in this software, right? Suppose if you install Microsoft Office or something which is owned by Microsoft, right? If you find a bug, you directly go to Microsoft and say that there is a bug, there is a support person who is going to help you within a few minutes, hours, or depending on the SLAs, right? Service level agreements, they will clear that problem. But for open source, right, that's a very big problem because it's free. Nobody is going to give you support for that. And if you put this software in production, right, then if something fails, your whole business might actually impact because there is no immediate solution which somebody is going to provide. There is no what we call it as support, and which is a big thing in production, right? So here the software was excellently created as an open source software, but the problem was with the support. So at the same time, right, a company called Cloudera, right? So this company looked at the software and it was doing great things, and they said that okay, the software is good, but it lacks support. So I will basically take this Hadoop software and I'm going to build a framework around it. The ultimate software is Hadoop, but I'm going to build a framework around it, and I'm going to give a name to it by calling it as CDH, Cloudera Distribution for Hadoop. So to the clients, right, if they want to install Hadoop, they don't want to install Hadoop directly. They will install this CDH product. And this CDH product is actually maintained by Cloudera, and any problem that they get in Hadoop, right, they actually address that and they meet the client's SLAs. So that will be a very plus point for many of the companies, because here the software is now cheaper, not in fact cheaper, it is actually free of cost, and they also are getting the support. And later many companies have joined in doing the similar things because you have competition, right? The same thing will be done by multiple people. But now I think you might have already heard about these two companies have merged, right? So these two big players, this is actually from Yahoo, and this is an independent company. They actually Cloudera acquired Hortonworks, and now it is a single company. And you have Mapr, which is from former employees of Google. They set up their own company, and they do the same thing. So these are called as distribution companies. So they take the same Hadoop software, which will be developed by some other people, and these companies take this software, and then you can use as client, you can use this software to build your applications. And you never want to use this Hadoop directly, which is called as Apache Hadoop, which is, if you are going to put this in production, you are going to land in a lot of problems, right? So that's why Cloudera, once the Cloudera started giving support, this Hadoop has become very popular because the way it was created was with so many advantages and distributed computing all behind the scenes, right? People were able to use this particular software, right? So that's how the software problem was actually picked. Now, the way the Hadoop software runs is, it was written in such a way that if a machine on which it is running, right, if it fails, it can actually run the same process on a different machine. That is the beauty of this software, right? In previous things, you had to take care of it, but now Hadoop software, if there are 100 machines and if 2 machines fail and there was already a process running, it can actually go to a different machine and continue the processing till your final results are published, right? So that's why we call this feature as fault tolerance, and Hadoop does fault tolerance very well. So that's why it doesn't, if a machines keep failing, right, you don't have to actually worry about it. You can actually run the software on other machines also. Which means that what does that imply? You don't need to use expensive hardware, because even if a machine fails, you can run it on a different machine, right? So that's why you don't need to have expensive hardware. You can actually use commodity hardware. So Hadoop uses, or Hadoop runs on commodity hardware, which is cheaper hardware, right? Even if it fails, right, it can run on a different machine. So you don't need expensive hardware, because previously what they used to do, if the machine fails, then they have to stop the whole processing and then redo it everything. That's why they use expensive machines. But a machine is a machine, right? Even though how expensive it is, at some point of the time it may bound to fail, right? So that's why you don't have that problem in Hadoop. So Hadoop has really become a very big solution, and companies started using the software left and right, and it has become very, very popular, even more with the Cloudera, Hortonworks, and these companies actually taking care of it, right? So what exactly is Hadoop? So big data is a problem. Hadoop is a solution, right? So Apache Hadoop is a software framework that supports data-intensive distributed applications under a free license. So here you can do distributed processing. It will do the automatic breaking of the data. It is going to distribute the data. It is going to process the data on multiple machines. It is going to collect it. So everything it does behind the scenes, the developer really need not worry about anything. So whenever you have a huge amount of data that you want to process, right, you are going to use Hadoop. If you have smaller data set, of course, database is the best. But whenever a database cannot handle the data, right, Hadoop comes into picture, right? And it enables applications to work with thousands of nodes. See here, when you are saying I have a lot of data, it means that you cannot store it on a single machine. So it's imperative that you have to use many machines. And Hadoop is well architected with to work with thousands of nodes. Nodes are nothing but computers and petabytes of data. And Hadoop is actually inspired from Google file system and Google MapReduce. So here, Google is the company who actually came up with this concept of distributed computing. So this GFS paper, right? Actually, Google has written a paper which says that if you have a large amount of data, you do not want to execute on a single machine. You always break it into smaller pieces. And how to do that effectively and efficiently and distribute it onto many machines, right? This paper talks about it, right? It is not a software, it's just a white paper on how to implement the technology. And Hadoop has actually taken this GFS paper and implemented a software called, of course, within Hadoop, you have something called as HDFS. It is actually inherited from this paper, Google file system. They call it as Hadoop distributed file system, right? And just distributing the data is not sufficient. You have to process the data. You have to query the data. That is the most important thing, right? And that they have actually taken care by Google's MapReduce. This paper talks about how to process the data. My query is not going to run on one machine. It's going to run on multiple machines. So how do I basically distribute my query and run it on multiple machines and also collect the results and then aggregate it and then give it back? So Hadoop has actually built its applications based on the Google GFS paper, which is they call it as HDFS, and the processing framework they call it as MR. And they created these two things as two separate components, right? And why do people go for Hadoop? Because it is accessible, it is robust, scalable, simple, data locality and replication, right? Accessible, you can run it on your local data centers or on the cloud. It is robust because even if machines are failing, it can still run. It doesn't just say I'm going to fail because one machine failed. And it is scalable because if you are having increasing amount of data, you can actually increase the number of machines and then handle it. And it is simple because most of the complicated technologies of distributing the data, distributing queries, all these things are already taken care. You just implement your own simple business logic, right? And data locality, the most important part of your system, which says move the computation to the data. Previously, when I had only one system, the data, I used to have the processing, the querying sitting only on one machine and taking the data on that machine, right? But now in this new version of the distributed computing, you are processing, right, which is called as compute. It will go to every machine where the data is located, right? So the process will run local to the data which is there on each machine, which is called as data locality. So we'll be discussing this during the course a lot. And replication, the most important thing. See, when a machine fails, Hadoop is able to process it on another machine, right? But how is it possible? The data is gone, right, on that machine. So Hadoop maintains multiple copies of the same data on many machines, right? So that it knows exactly where a copy of that particular piece is located on a different machine. So when one machine fails, it actually switches to another machine where it has the data and start continuing the processing of the data, which is going to be very, very advantageous. So a lot of business drivers, bigger the data, higher the value, financial drivers, the cost advantage of open source, commodity hardware. Commodity hardware is much, much cheaper than your main hardware, right? So your hardware is usually in hundreds of thousands of dollars, but commodity hardware is a few thousands, right? And a lot of technical drivers, you can take care of the 3 V's, right? The volume, velocity, and variety of your data. Now quickly, a couple of more slides and we'll actually take up questions there. And I'm seeing some questions in my comment section which I'm not able to go now, but I will actually answer them towards the end. Okay. So here Hadoop was actually created during the new millennium, like 2003. There used to be a developer at that time called Cutting. He was working on his web search project, and during the late 90s, right, his product was working well. So he created a search engine which searches across the web and then finds out the searches and then give links, and then people can search various things, right? But suddenly in the new millennium, his queries become slow. His search was becoming slow because this is the time when people started using internet, creating websites, and they had to search more and more data. And searching through the website's data is a very complex thing, right? So that's when he saw Google publish their papers like GFS and MapReduce papers, and he has taken that thing, and then he started writing the software. And during that time, Java was one of the very popular languages. So he used Java as the main language to create this Hadoop software like HDFS, MapReduce, and later the Facebook has become used by many people during these times, and then they also had hundreds and thousands of terabytes of data. So they said that, okay, we will join hands with you, and then we will also create components within the Hadoop system, right? So like this, many players who joined with Hadoop because it's being an open source, right? Many external players joined, and then they started building this particular Hadoop software. And where did the name came from? So as you can read here, right? So the name Hadoop is not an acronym; it's a made-up name. It doesn't mean anything because the Duck-Cutting's son, right? He was actually playing with an elephant which is yellow in color, and he used to name it as Hadoop. But he found that he was able to correlate the bigness of an elephant with the bigness of the problem he was solving. So that's why he took the elephant as the logo and yellow as its color, whatever it may be. And then it has really become, and Cloudera coming in 2008 and then adding support, right, which actually made it even more popular, right? And one of the very important things in Hadoop is that they did not actually create this as a single piece of software, right? So usually when you look at open source software, right, they are made as smaller components so that you can reuse them wherever you want it and use them only if you want it, right? So they're created, if you want to distribute your data and then store it on many systems, right, they call it as HDFS, right, Hadoop Distributed File System. And this is called as MapReduce, right? It is only for processing the data. And like this, and here the problem with MapReduce is that you need to know a language called Java, right? So the base layer they created as HDFS, and later they introduced Yarn. I will actually talk about Yarn later. But yeah, on this framework, they created this MapReduce framework. But this MapReduce framework is written in Java. And if you want to run a query, you have to learn Java language, right? And if you're coming from a database background, right, then it's very difficult to learn a new language and then convert your queries into Java and then run it, right? Very difficult. And Facebook also faced the same problem. So they actually came up with their own language called Hive. So this Hive tool, right, you give a SQL query just like how you run it in your database, and this will actually convert it into MapReduce program and then run it so that the developer really need not worry about the coding part of it. So that's the reason in MapReduce, right, initially people used to write MapReduce programs, but later this Hive tool is going to solve their problem and you don't have to write a single piece of code. You can just write your SQL queries. Just like Pig is developed by Yahoo, and they actually created, because their developers are not database developers, they're all scripting developers. So you write some Pig Latin scripts and then it will again convert into MapReduce program. So like this, Hadoop has become an ecosystem slowly, which means that ecosystem means collection of smaller things, right? So initially they came up with HDFS, then Yarn and Hadoop MapReduce, and then we have Hive, Pig, and Mahout, and there was Impala to run your queries faster on Hive, and then they had Zookeeper, a background service, then they had a NoSQL database called HBase. So like this, and also most of the times when the people were doing it, right, their data was already in databases, right? So you have the data already in, let us say, Oracle, right? Now, if I want to run a query on Oracle, it is not working, so I have to run it on I have to first get the data and put it in Hadoop, HDFS, right? So Scoop is a tool. There are a lot of data ingestion tools. So these tools are called ingestion tools. Ingestion means you basically put the data in another system, right? So if you want to put this data in Hadoop HDFS, right, to do the proper querying, then If you want to write MapReduce program, you can still write it, but Scoop tool automatically connects to your database and then start transferring the data into HDFS, right? And then Kafka is for dynamic processing of your real-time data. It will take and ingest the data. And then Flume is one of the Hadoop components. Kafka is not actually a Hadoop component. I just included here. But Flume is a Hadoop component which will ingest real-time data into HDFS. Kafka is a very advanced form of Flume, which has many, many features which Flume doesn't have, right? So like this, many components were developed, and learning Hadoop means it's not just about one thing. It is about learning many tools, right? So like this, I'm not showing all the components. There are like 20 to 30 tools that you have to learn if you want to be completely an Hadoop expert. But usually that doesn't happen. It's very difficult to master all of them. So you try to learn whatever is required, and depending upon your project requirements, right, you learn the other components, right? So we have Hadoop, HDFS, and then all the things. So Hadoop was working fine, and people were happy. So the queries that were taking 8 hours, 9 hours, right, now they were able to execute them in 30 minutes. Like I have already shown you, right? If you use a distributed processing, right, the total amount of time taken will gradually reduce from 23 days to almost like 33 minutes, right? So, but that is okay. But as and when the time passed, right, people again started cribbing about MapReduce, saying that MapReduce is taking like 30 minutes to process the data. Initially, they were happy, but later they were not happy. They wanted this data to be executing in maybe 30 seconds, right? And Hadoop cannot do it because it has its own, because of the way it runs, right? It can reduce it from 8 hours to 30 minutes, but from 30 minutes to 30 seconds, it may not be able to do it, right? So that's when a new framework has come into picture later, and they called it as Spark. And this solves the problem that the MapReduce is facing, right? And Hadoop Spark was a very new technology. It was created very old, but the people started realizing its advantages of late, and they started, a lot of projects have started using Spark. And the best part of this tool is, if you have already stored some data in HDFS using Hive tables, you can directly query from Spark, but it doesn't go through MapReduce, but it uses the Spark architecture, which is going to run your queries very fast. So if you have already executed a project and you have a lot of Hive tables created, you don't have to convert them into Spark. Your Spark can directly go take the data and run it in the Spark in-memory system. It uses something called as in-memory processing, which is going to give you very fast processing, right? We usually call Spark as a near real-time system. And Hadoop is typically used for batch-oriented processing, right? Batch means, as I told you, right, you don't wait for the result. You actually look at the result later. But for real-time processing, right, very much you have to use Spark because it processes the data in memory very, very fast. And it also came up with its own ecosystem components like Spark Streaming, Spark SQL, some MLlib, and graphics. And in this course, right, we will see some of these components which are currently being used in the market. Something like we're going to start with HDFS, we're going to learn the yarn architecture, we're going to look at the MapReduce, but I'm going to just show you one example of Java. Further, you don't really need to know Java, but if you start working on that a little bit, that should be good from the concept purpose. And then we are going to actually learn about Scoop, we are going to learn about Hive, we are going to learn about Impala, and then we are going to actually go into Spark. But as I told you, for learning Spark, you need a language called Scala, because they have not used Java. They actually used a language called Scala, right? So here, this language I'm going to teach you, and this is based on the Java language. So if you have some basics object-oriented knowledge of Java, right, it would be very, very advantageous, right? But I will make sure that you learn the Scala from the basics, and we're going to learn the Scala that is required for Spark, right? So just the enough knowledge that you require to learn the Spark technology, which should be pretty much straightforward, right? So these are the various components. And who uses Hadoop? Of course, Yahoo, Facebook, LinkedIn, and all these things. And finally, yeah, so Hadoop now has put its foot in many different sectors: financial services, healthcare, retail, web, social, manufacturing, everywhere. You can see, because everybody is storing huge amounts of data, and you definitely need Hadoop if you want to do very high-end analytics. Okay, so I think we just got overboard by maybe 10-15 minutes. Sorry about that. But I hope now you got a better sense of what exactly is the Hadoop and big data. So I may actually take up some questions. Millions. I think these are the comments usually. So anyone, any questions that I may answer in the next couple of minutes?
So can we use any other language for Spark other than Scala?
Yes. Spark actually supports 4 languages. First one is, of course, Spark is actually written in Scala. So you can definitely use Scala, and it is much better to use Scala. And of course, you can use Python. You can use Java itself, and you can use another language called R. Right. So these are the 4 languages that are supported. So these days, right, Python has becoming very popular. I don't know why, but many technologies are using Python as their language. So many people these days learn Python. So that's why what Spark also has done is they have implemented some libraries through which you can write the code in Python, but it will ultimately use the Spark framework. Right. So the only problem with using any other language than Python is that so these people have to implement that library in Python also, because by default they're going to write it in Scala. But if that same feature has to be available in Python, they have to write some libraries so that Python can also be used to write your Spark code. R and Java, they're not that popular, but many people use Java if they have a core Java language. They don't want to learn a new language. But the most popular languages are Scala and Python. Did that answer your question?
Yeah, thanks, Ravi.
Okay. So any other questions that you may want to ask?
So one more question.
Yeah.
So like, what is the difference between Hadoop and the machine learning? So both are data analytics. So how it differ?
See here, machine learning is basically a concept. It's not a language. It's not a technology, right? So ML is basically a concept, right? So it is based on something called as algorithms, right? So if you want to know one simple example, right? So here you might be doing a lot of shopping in Amazon, right? So when you buy a product, right? When you place it, when you click the place order, right? What is the next screen that you see? If you can just remember and tell me, anyone.
So
when you buy a product, when you say place order, what is the immediate screen that you are going to see?
So address or payment.
Adding more items if you want. Yeah.
You are already done the payment. Everything is done.
Means the person who bought this also bought this.
Exactly. Top popular products. So how they are able to decide that if you buy a computer, right? They say that people who bought a computer have also bought many other things, and they will lure you into buying more things, right? So what they have done here is they are also at the same time, while many people are buying things, they're also creating models behind the scenes saying that if I buy this, if a particular product is bought, what other products are being bought, right? So your machine is actually learning things on the background on what people are doing, and they create something called as models. So I don't want to go into machine learning now, but I'm just trying to tell you the difference. So it's basically a concept where you try to peep into the data using a lot of mathematical algorithms, right? So if you want to create a recommendation engine, right? Suppose let us say you look at a movie and you give a rating, and if a new user comes in, right, whether that user will like it or not, you want to your Netflix and those things, they're going to recommend you based on various other things, right? They want to recommend, right? Again, this is also an algorithm behind the scenes which is running, and then you want to analyze the data and then give you solutions. So ML you cannot compare ML with Hadoop. ML is basically a kind of what do you call? It's not a technology. It is a concept where you can actually build algorithms, and those algorithms can be written in many different languages, right? So if you want to find a solution for this recommendation engine, right, using Hadoop, you can use something called as Mahout. There is a tool called Mahout, which I have actually shown you here. See here, MAHOT, Mahout, right? That is the data, that is the ML tool in Hadoop, right? Suppose if you want to do the same thing in Spark, right? There is a Spark ML. So ML is a very generic thing which can be implemented in many different analytical engines. So ML is only talking about mathematical algorithms and statistical algorithms. That's it. It can be implemented with Hadoop. It can be implemented with Spark. It can be implemented with R. It can be implemented with Python. So you cannot directly compare whether to use ML or Hadoop. That's not the question here. Whether to use Hadoop or Spark is the question.
Mm-hmm.
You got the idea?
Sure. Understood. Thank you for clearing me that.
Okay. Any other final thoughts? Okay. So thanks for attending. Hope to see you soon. Yeah, that's pretty much from my side. Thank you.
Thank you, Ravi. Thank you so much.
Bye.
Hi, Dheeraj. Mm-hmm. Anybody there?
Can you hear me? 1 minute.
Hi, Dheeraj.
Can you hear me?
Yeah, I can hear you. So how do you like the training, the intro, the demo?
Yes, it went well.
Okay, sure. Okay, you can join into the office session. You can quit.
Okay, sure.
Thank you, Dheeraj.
Okay, thank you. Bye.
Hello, Ram Garu. Josna.
Yeah. Hi.
Hello, anybody
Hi,
there?
Ravi.